So this is the first part of the PowerPoint we went over in class, square root functions. I know we went over this pretty quick in class, so I want to spend a little time in the video going over it again. Now, square root functions are also known as radical functions, okay, because they have a radical. The square root is the radical, okay, two words for the same thing. The expression under the radical sign is called the radicand. Okay, if you're not already taking notes on what the vocab words are, please do. You need to know these vocab words. Now, the radicand can never be negative. So, underneath the radical, you can never have a negative number. That doesn't work. Okay, now when you get into Algebra 2, you'll figure out there's a method of dealing with that. But for right now, we don't know this works. However, so this doesn't work. However, having a negative square root works, or having the square root minus something works. Okay, so in this case, this negative sign is outside of the radical and therefore is not included in the radicand. And in this one, again, it's outside of the radical and is not included in the radicand. So only the radicand can't be negative. Now, the parent function for your radical functions is right there. F of x is equal to the square root of x. The parent function table is going to be over here. You're going to start at 0, 0, and then you're just going to take the square root of every number. So 1, the square root of 1 is going to be 1. 4 is going to be 2, and then 9 will be 3. Okay? Now, unlike quadratics, you don't need 5 points. However, 3, 4 points will help you get a good idea of where the graph is going. So at least go out to these 4 points. Okay? The type of graph is a curve. So quadratics was a parabola. This is a curve. Now notice our domain and range. Okay, the domain is no longer all real numbers. In interval notation, we would write this as 0 to infinity. And then same thing for the range. The range is also 0 to infinity. Now 0 is included as a point. You can see this on the table, so please make sure to include brackets in your domain and range. Now, the main thing I want you to pay attention to is the vertex function, or the transformation function, would be more accurate. That is a part of this still. So a, b, h, and k still work for these functions. It looks a little different, but it still works. There's the parent function. The transformation equation would be y is equal to a, b times x minus h plus k. Now I want you to notice a few things while you're looking at this. Number 1, all the letters are in the exact same spot. Okay, beforehand, b and h were inside the parentheses, but now they're under the radical. A and k are not under the radical. Okay, so same places, same signs, same jobs. Okay, the other thing I want you to notice is, I already said it, but I just want to draw your attention to it. K is outside of the radical. Okay, please be careful with your radicals. Make sure they do not extend to include numbers that are not within them. So always be very careful and deliberate with how you write your radicals so that something doesn't accidentally end up inside. All right, so with these functions, I'll do them in a different color, but you're basically going to do the exact same thing to each of them that you would have done beforehand. So in this one, we have a, and a is 4, which is a vertical stretch. Notice my vocab words stay the same, which means when I have my parent function, I'm going to apply a vertical stretch of 4 to my range, or to my y values. I missed a point. Okay, so 1, 4, 9, 0, 1, 2, and 3. So I would multiply all of these values by 4, which would give me 0, 0, 1, 4, 4, 8, and then 9, 12. And those would be my new values for the radical function. Okay, so if there's my parent function over there, my new graph is going to be 1, 4, 4. And then 9, 12 is almost off our graph, but it's about right there. Okay, so notice how it really did get stretched up. Okay, now on the next one, again, A. We still have an A. A is now -2, which means we're going to have a reflection and a vertical stretch of 2. Okay, please remember the negative sign has a completely different job than the number itself. And here's my new set of tables. Again, I multiplied only my y values by A. And then when I go to graph it over here, notice how it just flips over the x-axis and stretches a little. Not as much as my blue graph, but still a vertical stretch. Okay, now down here, next one. We have 2 transformations. Remember, they're all in the same spot. I have A is 1/2, which would be a vertical compression. And then I have K, which is a -1, which means all of my points are going to go down 1. And there are my new values. As you can see, I did both the A transformation, so the vertical transformation, and then I added K to my Y values and got my new points. These points over here are my final points. So basically, I added all my values to the table, or I multiplied, then I added my values to the table. Okay, so I have 0, 1, and then, oops, math error. That should be a 1. Okay, 1 and 1.5. Now notice how my curve is going to end up being flatter than my other ones. Okay, you can see the compression in this one. And there it is. Okay, it really did compress by half. Okay, also, another thing I want you to notice, none of my graphs have gone beyond the origin point yet. They all start at 0, 0, and then go forward from there. Okay, the letter that would make the arrow go the other direction would be B. If you had a -B, then you would have a horizontal reflection, and that would make the arrow go the other way. But we don't, so we don't have to worry about that. All right, last but not least, this one. So I'm going to show you how to do the table just because we've done the table for all of them, and so you can see how it works. Now, since I have H is 3. H is -3, which means I'm going left 3. So what I'm going to do is I'm going to add 3, or I'm going to subtract 3 from all of these points. So all of these points, all of my x coordinates, I'm going to subtract 3 from. So my new table would be -3, 0, -2, 1, oh no, that's a positive number. So we have 1 and 2, 3 and 3. Okay, notice how my y values did not change, only my x values did. I subtracted 3 from my x coordinates only. Now I'm going to plot these. And there we go. There's the graph shifted to the right, or to the left, 3 coordinates. All right, this is how you would graph. Like I said, the main thing I want you to see from this is that A, B, H, and K are in the same spots, and they do the exact same job. Let me know if you have any questions, and I'll see you next time.